All right, so here is ROS Exercise 3 for mobile robotics. Um, just gonna kind of go through everything I did. And for you, Dr. Woodfee, what I'm gonna be running off of here is the grading rubric. I met these two and this. So that's 60 points. I know how to do this, mostly, and I have not started this. So if we jump into it, creating the package and then making sure everything lines up here, I had a problem with this single pillar world. So that was because inside of the worlds folder up here in my ROS assignment 1, I had this single pillar world trying to run it without allowing it to execute as a program. Also, I needed to do chmod plus X for this file to give it execute capabilities. And then, as I can show, inside my launch file for exercise 1, now all I changed was just find ROS assignment 1 inside that worlds folder, and then there's the world. And this loads and launches. Don't need any teleapp as the exercise states. So that's all of the ROS 1 stuff that goes into this. And then if we jump back into over here, ROS assignment 3, I'll kind of lay out what I've got done. So we've got configuration, launch, and scripts files. Inside of each, there's this in the config, this in the launch, and the scripts have that. I changed the package and CMake lists just to make sure that they were lining up as just like exercise 2. So taking a look over here at our launch file 3, so that is in ROS assignment 3. So I'm loading in the parameters that I'm supposed to use, and this is just a YAML file where the proportional gain is set to 0.5. This part is associated directly with hitting the pillar. So that is the connection I don't quite have. But let's take a look, keep looking here. We've got launch file, we've got the parameter, finds that first launch folder, opens up RViz, and that's where I've got the configuration as I showed you earlier. And for the first run of the simulation, I'm only gonna have the, so what here, I'll show you these. I've got a subscriber right here, a publisher, and then I try to get both of them together. This one's the most complete picture, but it does not run correctly. So just for the first run of the simulation, it's just gonna be with this. That way it builds into it'll open the world and it won't be moving. And from there, I can kind of show RViz. And after that, I can open this back up and then we'll run it again for another simulation. So taking a look inside the brains here, the subscriber node, this is exactly what it looks like. Let me make it clearer. Exactly what that looks like. Just taking these to find the angle alpha, since over here we can see that the angle alpha right there is the angle from the x-axis. So this is the x-axis right there, the angle this way, that's what I'm calculating there. And the subscriber logs both that angle and the distance of the pillar as needed down at the bottom of the exercise. So that's what my subscriber set up to do. And then my publisher is set up to give a linear speed. So this is very basic. This just moves the robot in the plane. This isn't what I need. It's just the basic thing to move it. It's not actually what I need for the exercise. So let me get into that. What I would need for the exercise is something like this. I'll try to hold it straight. So just something like this, where the speed at the bottom here is controlled by that proportional gain over in the YAML file right over here, right? So I could use, taking a look over here at ROS param, just using a ROS param get or set, and so I that's the one piece that's keeping me from completing the publisher, because basically it needs to take from here we go, the subscriber, it needs to take both this angle and the range to it for me to get it set up. And so basically, if this was running correctly, what would happen is give it some threshold angle. So give it a threshold angle that it can move off of. And if it's too great, if the angle is too great, say the pillar's over here and I'm facing this way, if this angle is too great, it only does the angular until it gets right in line or within that threshold, and then it hits the linear speed, which is just a function of the twist. So then it moves forward, and then it can keep adjusting if it runs out of the bounds. And then it should hit, straight up just hit the pillar. So that's not hard. Just don't know with the way I've got this set up how to connect between the subscriber to get both of these values, A and CL range, over into the publisher and get this parameter here just as like a multiplier. So multiplier control. So yes, do we cover everything? Yep. So this is the idea of what it should be. This is not actually what works. So let's go ahead and run just the subscriber node. This is a subscriber simulation. And to do that, I'm gonna need to Control-Alt-T, pop it up, and this is gonna be just a bit. Let me get in here. And we're gonna do ROS launch, ROS underscore assignment 3, and then we're doing a launch file 3.launch. So a quick note, before anything pops up, what I'm expecting to see is the world loads. We've got the single pillar world, that loads, the Husky loads into the world, and it does not begin driving just because we're only doing the subscriber node. That's all we're doing. I just have a few comments about that, so that's why I want to go this route. All right, give it a go. There we are. Husky, and then pull out of here. There's the pillar right there, right there. The Husky is looking at it, just like this. It's got that angle. And first let's take a look at the RViz. So you can see I have, I've got some sort of marker. That's not the exact marker that I need for the thing. The robot model's in there, TF and laser scan. So TF would be, if I zoom in, the robot's kind of own coordinate system, as you can see there. And laser scan would be scanning for the pillar, which hasn't been made yet. So that's the reason why that's not showing up. But all of these markers over here are in the configuration set. It is ready to go. So last thing to look at is our terminal. Boom, there we go. distance, you can see distance to pillar, and angle right there. So our constant angle is about 0.24577. That's a constant angle in radians, and then our distance is right about 20.1. So the easy way to get that into an XY thing, it's really easy with the cosine or sine. So that's where we're starting from. That would be something I need to factor in, right? Because that's where we're starting. I could use that for the visualization, putting this cylinder inside of here accurately, hard coding that. So that is just with our subscriber, our listener. So Control C, and I'll show what happens when we get the publisher also in there. So let me uncomment that. All right, and save. Waiting for it to exit. Okay. Run it again. So what I'm expecting to see now is, because this includes I'll show it again, right here, a linear speed, it should straight up start moving along the X direction. So it should already be off the X direction right now. Robot model hasn't loaded in RViz, I'm not worried about that. But let's see if that's true. When it pops up, our global XYZ, the robot should not be there. Boom, caught it just a little bit over here. There's our XYZ, the robot's not there. Where is it gone? This is the X, this is the red, this is the X. If it'll allow me to zoom out and twist. There we go. See, robot is moving along, a little too far, but moving along the X axis there, and there's our pillar right there. If I look here, it's long ago past, so it's like 180 degrees ish. So that's what the angles and stuff are telling me. And if we take a look at RViz, we can see right down here, it's traveling. So it shows up, it visualizes. The only thing is, again, I don't have the code connection to get it straight into the pillar. So, all right, that's it for what I have. One sec. Just another note. Open this up. So again, I know how, I have a good conception of how everything works beyond this, how to get it into the pillar. I don't have the knowledge for taking the parameters out, or these values, these specific values in the subscriber node. Taking the A and the CL range, taking those and bringing them into the publisher for use under the speed function here, which is a function of twist. So that's the holdup, and this is as much as I will get done with the time I have, I think. So thank you for watching. I hope this was informative, and I will send you my files, and everything should be done for ROS Exercise 3.